In this video, we talk about Apple's M1 chip, their split with Intel, and what that would bring for the tech industry. Apple's Big Mac event, held on November 10th, 2020, delivered 3 new computers, a new MacBook Air, a new entry-level 13-inch MacBook Pro, and a new Mac Mini. But really, it delivered one thing that those 3 computers have in common: the M1 chip. That's the new official name for the ARM-based Apple Silicon processor that Apple is going to migrate all of its Mac computers over to. Apple will no longer rely on Intel chips for its Mac lineup. Instead, the company's homegrown ARM-based processors, called the M1, will be replacing Intel. Apple's Bionic chip, which is already a staple of the iPhone and iPad, will provide the brains for the future of Apple computing. The shift to so-called Apple Silicon is monumental, not just for the performance gains of Apple's laptop and desktop lines, but for the surprising convergence of all its devices. The first ARM-based Mac will be available by the end of the year. The company expects the transition to take 2 years in all, and will continue to release some Intel-based products until then. The Silicon shift gives Apple new control over its own destiny, and perhaps the future of the personal computer. Apple and Intel's relationship dates back to 2006, when the former transitioned away from PowerPC processors. The switchover was rocky for a year or two, as developers had to update their software to accommodate Intel's x86 architecture. Think of it like translating a novel into a new language. The task awaits developers again, although it looks to be less onerous than the previous switchovers. On June 6, 2005, at WWDC, Steve Jobs officially stated that Macintosh would be switching over to Intel processors. In a nutshell, the PowerPC G5 processor that they were currently using generates too much heat and uses too much power. Even more so, such a chip would not be able to be used in the thin, light systems that we see in today's iMacs and MacBooks. It was a big move by Apple to switch from IBM-built PowerPC processors to the x86 processors made by Intel. As Jobs promised, the entire Mac lineup was moved to run on the latest Intel chipset by 2007. The first Intel-powered Macs, the iMac and the MacBook Pro, were announced in January 2006. By switching to Intel for the first time, it was possible to run Windows on the Mac computer. In 2006, Apple introduced Boot Camp, a brand new way to natively run Windows XP on Mac. The change brought about many new innovations in Apple's lineup, particularly in design. The iMacs and MacBooks we see and use today are incredibly thin, lightweight, and extremely powerful. Increasing power is no small feat, as shrinking down transistors is the most attainable solution. With this, however, the power consumption and heat generation tend to go up. It's a balancing act that Intel was able to deliver over its 15-year partnership with Apple. The Mac, meanwhile, has been an outlier. Because it relies on Intel's processors, it can only differentiate features so much. It can't optimize for power efficiency nearly as well, and left Apple beholden to an Intel production timeline that has increasingly been beset with delays. Francois Piednoel, a former Intel engineer, told PC Gamer that Apple has become unsatisfied with Intel processors since the introduction of the Skylake architecture in 2015. The report states that Intel's Skylake processors had several problems at the time, and that Apple was the client with the highest number of complaints about the architecture. The quality assurance of Skylake was more than a problem. It was abnormally bad. We were getting way too much citing for little things inside Skylake. Basically, our buddies at Apple became the #1 filer of problems in the architecture, and that went really, really bad. Apple first used Skylake processors with the 2015 iMac, and then the company also launched the 2016 MacBook and MacBook Pro models with the same processor architecture. Touted as one of the worst models, the 2016 MacBook Pro had numerous issues such as screen backlight issues, keyboard caps breaking, and various overheating problems. Not entirely Intel's fault, but Apple's chassis design architecture to support the already high heat output of the chip resulted in several major issues in the model. In an earnings report this week, Intel said it's delaying the new 7nm processors by approximately 6 months. Intel's 7nm chips now aren't expected until 2022 or early 2023. Meanwhile, top rival AMD is already selling 7nm chips for PC and gaming units. Intel has struggled with multiple yield issues over the years, which has led to chip delays and roadmap changes. Intel's issues are perhaps one of the reasons that Apple had decided to ditch the Intel chips in favor of its own ARM-based chip technology for Macs. Apple has in the past been forced to delay updates or use older chips because of delays in Intel's production plants. Intel's chip delays show exactly why Apple is switching from Intel to its own chips for its Macs. Once Apple makes the transition, which it says it will take about 2 years, it will no longer need to rely on Intel's product cycle before it can deliver new Macs to the market. On Monday, November 10, Apple outlined several failsafes to ensure as few bumps along the road as possible. It will ship with Rosetta 2, an emulator that will let ARM-based Macs run Intel software from any lagging developers. The M1 will allow for virtualization on Linux. Although Apple has been mum about whether Macs will continue to be able to load Windows through Boot Camp or virtualization software. Most intriguing and unexpectedly, iPhone and iPad apps will be able to run natively on a Mac. Apple is designing its own range of chips for Macs, with features unique to Mac. The common ARM-based architecture across Apple's products should now make it easier for developers to write and optimize apps across every major Apple device. Apple has used chip designs from ARM as the basis for its iPhone processors since 2010, when it shipped the A4 processor in the iPad and iPhone 4. Since then, the company has been able to develop its mobile hardware and software in concert, finding efficiencies and targeting specific performance gains in a way that competitors have since tried to emulate in increasing numbers. If you control your own silicon, you can also offer features that competitors can't match, as Apple did with the iPad's Retina display powered by the A5X processor in 2012. In 2017, Apple expanded its own solo efforts to make its own GPU, better positioning itself for an augmented reality future. The M1 is similar to Apple's iPhone and iPad processors, allowing mobile apps to run on its new PCs and bringing improved power efficiency. Making its own mobile processors has helped Apple innovate with such features as facial recognition and augmented reality on the iPhone. Designing its own chips for devices like the MacBooks and Mac Mini, announced Tuesday, should also allow Apple to be more creative with PCs. When chip, device, and software engineers work closely together, they can squeeze more performance out of a device than is possible with an off-the-shelf chip. In Tuesday's event, Apple software chief Craig Federighi boasted that the new MacBook Air can wake from sleep more or less instantly, similarly to the smartphone or tablet. The company also touted impressive battery lives for its new M1-based MacBooks, up to 20 hours of video playback on a single charge. Apple's chip change has been in the works for years, but appears well-timed, because it could help the company deal with two major challenges in the computer business. Intel still dominates the market for PC and server chips, but has still struggled to launch its two most recent generations of chip-making technology on time. Using its own chips, designed in-house and manufactured by Taiwan's TSMC, frees Apple from Intel's troubles. The conventional strategy of making more powerful chips by making transistors smaller is becoming more difficult to sustain, because the devices are already measured in nanometers. Switching Macs to TSMC-built processors of Apple's own design vaults its PC onto the smallest, best chip manufacturing technology. That offers both performance gains and cash savings, because smaller processors are more cost-efficient. Apple should also be able to extract more performance from its chips by tightly integrating them with its software and adding special features like its neural engine. Apple's event on Tuesday left some questions unanswered. The company said that the M1 would appear in lower-end Macs. The MacBook Air, the smallest MacBook Pro, and a Mac Mini desktop. The company likely has a second chip for its higher-end PCs, the Mac Pro and iMac, which are commonly used for computational heavy lifting, such as designing special effects or large-scale video editing. Apple's new design freedom could prove to be influential on other PC makers, just as the iPhone has shaped the smartphone market. The rumblings around the transition to ARM have focused particularly on the architecture's ability to handle professional-grade apps. Apple went some way to help alleviate those concerns Monday by showing off its Final Cut Pro video editing software running natively on Apple Silicon, as well as Shadow of the Tomb Raider and the extremely intensive 3D modeling software running smoothly through Rosetta. It translates the apps when you install them so they can launch immediately and be instantly responsive, said Craig Federighi. Rosetta 2 can also translate code on the fly when needed, like web browsing. It even handles the most complex Pro apps and their plugins. The A-series chips in Apple's iPhone and iPads do hold their own against their lower power Intel comparables, but it remains to be seen how quickly Cupertino's Silicon team can level up the chip's capabilities even further. Based on the company's transition timeline, the answer seems to be 2 years or less. In the end, it all comes down to what an ARM-based future means for us. A world in which you don't have to buy iPhone apps, or iPad apps, or Mac apps, but just Apple apps that work on whatever device you own. Even Microsoft has their own lineup of products already integrating ARM-based chips. Seamless integration across the board. Of course, Apple's move to make the transition from x86 to ARM would make Intel a bit nervous, even if Apple's global market share in the computer segment is less than 8%. The switch from Intel to ARM shows that Apple does not need Intel anymore. But with both Apple and Microsoft switching to ARM-based chips for their future lineup, and AMD already taking over some of the share in its own chipset development, Intel has some reason to worry. We'd like to hear your thoughts about Apple's M1 chip and the future of PC. If you enjoyed this segment and would like to see more, consider subscribing and give the video a thumbs up. And I'll catch you all in the next one. Peace.